Hey guys, I'm CG Smoothie and welcome back to another Unity tutorial. This will be a pretty in-depth tutorial on how to make an adaptive terrain footstep audio system. Think of a game like Minecraft, where each block has a specific sound effect when you step on it and break it. If you were making a game like Minecraft, this system is easily expandable to add different sounds for different terrain interactions, like breaking and placing, but I will stick to footstep interactions. I've spent a lot of time refining this to be as helpful to you guys as possible, so if you have any questions, please feel free to ask in the comments or my Discord channel in the description. For this tutorial, I will be using a basic 2D scene that will be available for you to download in the description down below, with this beach consisting of water, sand, and a cobblestone path, and a little CG Smoothie player character with animations and a basic top-down 2D directional movement script. I also have two other way less polished versions of other game types, because you can use this with any game type you'd want. However, if you already have a game set up and you are looking to spice it up with this kind of system, this will work with both 2D and 3D games, and I'll explain where and how the two differ. First, we are going to create a terrain behavior script. If you have a 2D game, assuming you have rule tiles, we're going to replace them with a new asset called terrain rule tile. If you didn't, don't worry, I can still explain how to make those tiles or anything else work with this system. Let's create a new C# script and call it terrain behavior. This is where we're going to create any new types of tiles we might need, like rule tiles with terrain, or just tiles with terrain, or even animated tiles with terrain. My scene only contains rule tiles and normal tiles, so I'll stick with those two, but it is very easy to add new types. A slight warning that animated tiles will probably be harder to migrate over to this new system, because unlike rule tiles, there's no simple way to take all the sprites and copy them to a new animated tile. So just make a script called terrain behavior and open it up in Visual Studio. In our new terrain behavior script, let's create a public enum terrain types. An enum is short for enumeration type. What an enum does is make a new ID that is shown in editor as a string. So if we make that enum and call these terrains sand, shallow, and stone, in the editor, they will show up as sand, shallow, and stone, but the game will actually keep track of them as a single integer, 0, 1, or 2, which will save space, but make it easier for you as a game designer to know what you're doing in the editor. We will also create another field for a terrain type, and we'll call this terrain. So public terrain types terrain. This is what we will assign for each object in the inspector, and we will only have to edit the terrain types enum if we want to add or remove a new terrain type to the whole project. This terrain behavior component can now be added to any object, and you can choose a terrain to apply to it. So, like so, if I add a 2D object and add a sprite of a square, if I add the terrain behavior to this new square object, you can see I can change the terrain type, and if I add a new type called wood in this enum, you can see it with the component on it. Like so. But I don't actually need any wood for this scene, so I'll take it out of the component. This is all you will need if you're using a 3D scene, so if you're using a 3D game, you can skip to this time code for the next part of this tutorial. But for all you 2D game makers, if you're using any tiles, if you're not using any tiles, you can also go to that time code. But if you are using tiles, we also want to make new tiles for easier terrain detection, since we don't have that extra dimension to tell what is directly beneath us. Especially if we have layered tile maps on top of each other, it will be very difficult to tell what terrain is beneath us. To make new tiles, we will need to make another C# script and import the tile map's namespace. So let's create a new script and call it terrain rule tile. And double click on that. First, we're going to want to import the tile map's namespace using Unity engine.tilemaps. Then we'll create a new class, public class terrain rule tile rule not rule override tile, just rule tile. The colon means that we are inheriting our new class from the rule tile class, so it will have all the same functions that a basic tile has, like being added to tile maps and having a sprite and default collision shape, and also all the rules. We'll give it a new field for a public terrain behavior.terrain types terrain, so we can assign this rule tile, a terrain in the inspector. We also need to add a create asset menu attribute so we can actually create a new tile in our project. To do that, above our terrain rule tile, we're going to, in brackets, type create asset menu. We also want to add a variable for the menu type so that it's with all the other tiles. So in parentheses, add menu name equals 2D /tiles /terrain rule tile. Now we just need to do the same thing but for a tile. So I'll just do a little speed art of that. So see you then. I don't know why I snapped. Make sure that your scripts, if they don't show up in your inspector, sometimes it'll say mono behavior not found in your script. Just make sure, try adding a space in between each capitalized letter. If that doesn't work, then remove those spaces, and sometimes it'll just fix itself. I don't know why that just happened, but yeah. We are now ready to convert these tiles to their new tile types. In our project, right-click, 2D tiles, and then our new tile types show up here. To convert our old rule tiles into our new terrain rule tile, we just need to click our old rule tiles. First, let's add a new one, and we'll call this sand terrain tile. I'll just call it sand terrain. And then in my old rule tiles, click our old rule tiles, click the top right kebab menu. That's apparently what this little thing is called. Under this kebab menu, click copy all rules, and in our new terrain rule tile, you can paste rules like so. And then also add the default sprite if you want. And then just make sure that the terrain matches the terrain that you want it to work as. Because this is a sand, I want it to make a sand noise. And I'll do that for all our rule tiles right now. Make sure to, if you just duplicated your old rule tile, to reset before you paste new rules. If we did that for all of our rule tiles, we can also replace the normal tiles with our new terrain tile and then replace those all in our tile palette. So I'm going to replace that normal tile and then I'll get back to you. And also remember to change the terrains for all these tiles. Now we can replace these normal tiles with our new tiles in our tile palette. Sometimes a strange error might occur where the tiles become red, but if you select the grid, it should be pretty easy to fix this by then clicking the select tool in the tile palette and then selecting all tiles on each tile map and recoloring them back to white. And once you've done this, make sure to use the paint bucket on all of these tiles with their new tiles, because they will still be using their old tiles if you don't replace them with the paint bucket. So that should be it. We can check again if we use the inspector and use the select tool. It says sand terrain, and in the pathway it says stone terrain, and in water it says deep water terrain and shallow water terrain. And like I said, sometimes the color might be red. Just change the color here when you select all like so, and then you can change the color back to the right color. But I didn't have that problem for some reason this time. So Just letting you know that that can happen. Our tiles should now be fully replaced with our new terrain tiles. Now we can mate back up with our 3D members. On our player character, we are going to add a new script and we'll call it Footstep Audio. And we'll create an ad. This script is going to actually make the footstep sounds and also be where we edit what sounds each terrain can make. The first thing we're going to want to do is create a new class above the mono behavior. This class will be an editor class, which will actually let us edit the sound effects used for each terrain type. We need to add the Unity editor namespace though, and then add the attribute custom editor type of footstep audio. This attribute will link the editor to the footstep audio component, so even though there will be two classes, they both directly impact the same component. Next, we need to make a public class footstep audio editor, inheriting from editor. In this class, declare a footstep audio FSA, and then in the onEnable method, set FSA to the footstep audio target that we declared in the custom editor attribute. This is the target, the type of footstep audio. So equals footstep audio target. And that will fully link up the two classes. Next, let's also add an onInspector GUI method so we can affect the GUI. In this method, let's also make sure that it has base.onInspector GUI. Back to the original class, we're going to create another class within called Sounds. We can also get rid of all these start and update for right now. We don't need it. Create a public class Sounds, which is how we're going to declare all the sounds for each terrain type and their behaviors if you wanted to add a breaking behavior as well, but we're just using footsteps. We're going to give it a hidden but public string terrain type. You can hide variables while they are still hidden by using the attribute hide in inspector. We are also going to add a public audio clip array and call it footsteps, and just initialize it as an empty array. We will edit the arrays in the component itself in the inspector. Let's also create a parameterized constructor for these sounds, with the parameter just being a string for this terrain type. So just make a public sounds and also add the parameter of string, terrain type, and then terrain type equals TT. Then under this, we're going to create a list of these sounds. I think we want to make it a public list of sounds and call it terrain database. And we're going to initialize this as an empty list. Back in the editor class, we're going to add the part of the component that fills the terrain database with the names of the terrain we defined in this terrain behavior class, enum. Create a method with a void return type and call it update database. We are going to grab the names of the terrain types and put them in a string array by using system.enum getNames type of terrain behavior dot terrain types, and then also add this to a new array, string array names equals that. I don't know why I did a string array. We're just string array names. This part isn't strictly necessary, but it saves you a bit of headache from writing fsa.terrainDatabase every time you need it, which will be quite a few times. So we're going to create a new list in this method called temporary terrain database, or TDB, which means terrain database, and set it equal to the FSA's terrain database. So list fsa.sounds, or footstepaudio.sounds, temp tdb equals fsa.terrain Oh, make sure that the list is outside of the sounds. FSA.terrain database. Here we will make a loop to compare if there's any new names in the terrain type list that aren't in our terrain database, so we can add the new ones. Make a for loop for int I equals 0, I is less than names.length, and I plus plus. We are going to do this instead of a for each loop so that we can tell what index we are looking at faster. Inside this loop, write a boolean that says if we found the name in the terrain database initialized as false. Then nest a for each loop to run through each terrain in temp database. So for each footstep audio.sounds sound in temp database, if we find a terrain with a name that matches, so if sound.terrain type equals name, we will mark the boolean as true. So mark found equals true. If after the for each loop we still haven't found anything matching that name, add that. So if found equals false after this, or if not found, after the for each loop, meaning there's no sound with that name in the current database, then we can add it to the list using temp_tdb.insert at I new footstep audio.sounds name, or names.I. After this for loop, update fsa.terrain database equals temp terrain database, and in onEnable add the update database method. And now if we save this script and we look at our component on our player, it should populate our database with all the terrains. Make sure that your sounds are system.serializable so that we can actually see them in the inspector. And now you should be able to see it in the terrain database. We have all of our terrains. If we add a new terrain to our enum, like wood, and save it, it should also populate once we save it. However, if we delete that new terrain and save it, it will not delete in our component, so we will need to create another loop to remove any names that aren't in the enum after adding. So, before we did this, fsa.terrain database equals temp terrain database, we need to initialize an int for a delete index at 0. So int delete index equals 0. Then create a while loop for while delete index is less than temp tdb.count because it's a list. In this while loop, create another boolean found and set it equals to false. Now check for each string name in names. If it matches the name at the delete index, then we should increment the delete location and set found to true. And then after that for each loop, if it is not found already, remove that sound at the delete index. So if we don't find it in the enum, then we should delete it because we don't want that sound anymore. So temp ddb.remove at delete index. And then after that, do not increment the delete location at this point because the list of the temporary terrain database has now shrunk. So it should act like it's incremented anyway. Now if we save, our terrain database contents should fully match up with the enum's contents. Like so. And if we just stress tested it a little bit by adding a bunch, those should all populate once it's done building the scene. And then if we get rid of all of those, they should be destroyed. Very simple. So that's the hard part done. This next part is going to be a lot more segmented because different games will have different definitions of underneath the player. I've segmented these into 3 different categories, being top-down 2D, which also includes isometric games like Qbert, every other 2D game, and every 3D game. However, all 3 categories do need the same basic setup, so let's do this before we split up. Every type we'll need in the Footstep audio. Under this, we're going to need a public layer mask, terrain mask for our calculations, and then a public transform foot position to shoot raycasts from. I'm going to need some booleans because I'll split up the code on my end, but if you don't need all 3 systems, feel free to just do the type you need, and you don't need any booleans. But I do, so I'll need a boolean for 2D and top-down. We're also going to need to declare an audio source for the sounds to come out of. So audio source AS, and we're just going to make that be a new audio source that initializes itself on awake, because if you have a character that makes its own sounds different, it's just easier to make a different sound on awake. So AS equals GameObject.addComponent audio source. Finally, the last shared bit will be making a step function. It doesn't need to return anything, so it can be a void return type, and we're going to need an integer for a terrain type so we know what sound to play. So make an int terrain type and initialize that as -1 so we know if it changes. There's the shared bit. So time codes for 3D and non-top-down 2D games are going to be showing up now, and we will all reconvene to finish up with the shared bits at the end. Top-down people, we have the hardest job here, unfortunately, since we can't just use what is directly underneath the player, as there might be multiple sprites overlaid on each other if there are different tile maps. It's not too difficult though. First, we need to get an array of all the things directly underneath our player's foot, which in this case would be behind the player or in the direction of transform.forward. So you can do that by making a raycast hit 2D array hits equals physics 2D dot raycast all foot position dot position, and also make it go out a little bit, so minus transform.forward, and then it's going to be going in the direction of transform.forward at a max distance of 5 and at a layer mask of terrain mask. If the hit array shows up as empty, we want it to return now so that we don't waste any time or cause any errors. So if hits.count or hits.length is equal to 0, return. Next, we're going to want to keep track of the topmost object in the hit array, so we're just going to initialize that as the first object in the array. So GameObject top object equals hits dot collider dot GameObject. Since we already have the first object in the array accounted for, we will then make a for loop starting at the second object in the array, cycling through until it reaches the end. So for int I equals 1 until I is less than hits.length I++, and if the object at the index's sorting order is greater than the top object's sorting order, so if hit.i.collider.getComponent renderer.sorting order is greater than top object.getComponent renderer, which would mean it's higher up on the rendering, so it would render on top of it. Like if you had the stones in our scene that are partially transparent, so they would be on top. if they are greater, we should replace the top object with the object at the index. You also might want to add another thing to see if it's still less than the player's sorting order, which we can do with another predicate with an and. So if this and hits .i.collider.getComponentRenderer is less than GameObject.getComponentRenderer.sortingOrder, then we do that. Then we'd want to get the tile map of the object, which is assuming that we are using the tile map for all of our environment sprites. If you aren't, add an if statement checking if the top object has a tile map. So if topObject.getComponent tile map, we also need to import unity.tilemaps. So if the top object has a tile map component, then we do that thing. But if we aren't using a tile map component, we can just get the top object's terrain component and the terrain type from that, or terrain behavior. And then the terrain type we can just initialize as the int version of tb.terrain. But if we are using tile maps, we are going to need to get the tile directly under the player, which we can get by getting the tile in the tile map that matches the position of our foot object. So tile map tm equals top object.getComponent tile map, and var top tile equals tm.getTile foot position, right? Oh. Don't use greater than and equal. I don't know why I did that, but yeah. Also make sure that we get the tile at tm.world to cell footstep position.position. So if that tile's type returns as a terrain tile, type of terrain tile tt equals top tile as terrain tile. And then terrain type equals int tt.terrain. And else if top tile.getType equals type of terrain rule tile trt equals top tile as terrain rule tile, terrain type equals int trt terrain. We should be done now, so use this time code to get to the end where we put it all together and test out the system. Welcome back. For 2D non-top-down games, it's pretty simple. Let's define a raycast hit 2D. Hit equals physics 2D dot raycast foot position dot position negative transform dot up probably 0.1 and terrain mask. And if that hit is null, we don't want it to do anything, so we'll just have it return, because that'll save time. If hit equals null, return. If hit.collider equals null, actually, then return. And if it doesn't return null, then we check if it has a tile map. We want to get the tile directly underneath the player. So we'll take the if hit.collider.getComponent tile map. We will get that tile map. So tile map tm equals hit.collider.getComponent tile map, and then the tile at the cell position of the hit, hit.point, and then also further down a bit, because there could be some errors when I was playtesting where the hit's point can sometimes be outside of the boundary box for the actual tile. So we're just going to get the tile minus transform.up divided by like 8. So it's just a little bit more inside. Actually, instead of transform.up, we want to do vector2.up. And also make sure we do convert this point from world to cell. If that top tile's type matches the type of terrain tile, then we want to get that terrain tile as top tile, or terrain tile tt equals top tile as terrain tile, and then terrain type equals int tt.terrain, and then just do the same thing for terrain rule tiles, else rule tile trt.terrain. And if we weren't using a tile map, but you still want it to interact with this system, then we can also else if it.collider.getComponent terrain, and we can also just put that in the else function, else predicate. If the hit also has a terrain component, then we can get that terrain, or not terrain, terrain behavior. Terrain is a different component. Terrain behavior tb equals hit.collider.getComponent terrain behavior, and terrain type equals int tb.terrain. That should be it. So now use this timecode to get to the end where we're going to put it all together and test out the system. Welcome back. For you 3D games, it's the easiest. We're just going to declare a raycast hit, and we're going to call it hit. If we get a hit, if physics.raycast foot position negative vector3.up out hit, and then I'd say 0.1f as the max distance, and the layer mask will be terrain mask. And make sure you get that parentheses all sorted, which means if that physics returns a hit, then we can, if that hit has a terrain, terrain behavior, then terrain behavior tb equals hit.collider.getComponent terrain behavior, terrain type equals int tb.terrain. Now we should all be back. If that terrain type is no longer -1 after our raycasting, then we should be able to get a sound. So if terrain type doesn't equal -1, we should be able to get a sound from our terrain database array using the terrain type as an index. So audio clip sound equals terrain database at terrain type dot footsteps random dot range 0 to terrain database terrain type footsteps dot length. And that should randomly pick a sound from that terrain type, and then we're going to have the audio source play that sound using a play one shot method, as.play1shot sound. And we use play one shot because if we have a particularly fast walk cycle, this will allow us to play multiple sounds over each other. That's it for scripting. Now we just need to put it together. In my project, I already have sounds for sand, stone, and wet sand taken from a certain game. So I'll just drag each sound into their proper terrain category. And I would tell you to lock the inspector for this section because you can't select multiple things without overriding the inspector. So just dragging my sounds into their proper category. And make sure to add a foot object if you haven't already. Mine is right in where the foot would be of this smoothie character. And dragging it into our foot position thing. And then also create a new layer for all your terrain objects called terrain. I already did that, so just add a layer and make it terrain, and then all your terrain objects should be in this terrain layer. I'm also going to delete this square. And finally, in your player, with any animations where it hits the ground, add an event pointing to our step function in our Footstep audio script. So I have quite a bit of animations for this character, so I will speed through this section, but you just add an event with this button, and then choose your function, methods, step. And then I'll do that for all of my animations. Once that is done, you should be able to press play, and it should work as expected. It only didn't work as expected for me because I forgot to mark my booleans to be correctly. Also make sure that in your Footstep audio component that your terrain mask is set to terrain. Now it should work for me. And it does. I will now show it in all of my 3 game types now as well, just to prove it working. You might need to adjust how far down the raycasts go. I think my raycasts were a little bit too strict, so I'm doubling them a little bit. Just doubling them a little bit, as syntax is as a word. And then it should work. And it does. And then in my 3D scene, it should also work. Once I add all of my events again. And in 3D, it also works. I didn't put any terrain variation in this scene just because it was a very simple test to show you. Because I don't like making 3D games as much. I will also put a finished version of this project as a link in the comments section if you happen to have anything going wrong and want to figure out why mine may be working and yours isn't. But now you have successfully spiced up your Unity game with some adaptive audio. Doesn't that make it feel more real? As I mentioned before, if you wanted to add other sounds for each terrain, you can easily do that by adding a new audio clip to your sound class, like called public audio clip array breaking. For each behavior, like if you were making a Minecraft type sandbox game, you can add an array for placing and breaking, or for objects colliding with it, like if a metal object collided with a wood object, you could have a whole system just for that. This could just be the beginning of your adaptive audio journey. If you enjoyed this tutorial, make sure to check out my Discord where I show off a lot of things that I'm working on, and there's also a community of Blender and Unity users in there to bounce ideas off of as well. And if you did like it, make sure to like and subscribe to be able to see more of my Unity tutorials show up in your recommended, as well as devlogs of my own projects that might interest you. With that, I'll see you guys next time. Bye!